Okay, in this video, we're going to study limits involving infinity. Our first assignment, we're going to investigate the behavior of powers of x as x goes to plus infinity and minus infinity. So we're going to look at the behavior of x to the power n, where n is a positive real number as x go to plus infinity first, and then we'll also look at the case as x goes to minus infinity. We are going to do a numerical analysis here. So we're going to tabulate values. So we're going to look at x. So x goes to infinity means we're going to start, for instance, with x equals to 10, then go to x equal to 1,000, then go to x equal to 10,000. So first, let's see what happens to x squared, which is a power of x. So if x is 10, x squared is going to be 100. If x is 1,000, x squared is going to be 10 to the power 6. X is 10,000, x squared is going to be 10 to the power 8. The thing we notice straight away is that as this is becoming bigger and bigger and growing towards infinity, this is also going towards infinity. Okay, so x squared goes to infinity as x become bigger and bigger. Let's just do one other power here. Let's do x cubed. So for x cubed, when x is 10, this is going to be 1,000. When x is 1,000, x cubed is going to be 10 to the power of 9. And then when x is 10,000, x cubed is going to be 10 to the power 12. And then again, we notice that this also goes to infinity. Actually going to note that this goes to infinity even quicker than x squared. So we can see that as x goes to infinity, all powers of x go to infinity as well. Before we conclude, well, let's see what happens if x goes to minus infinity. We're going to construct a similar type of table. So 10, 1,000, and 10,000, so negative this time, because we are investigating the behavior as x goes to negative infinity. So what happens to x squared as x goes to negative infinity? Okay, when x is negative 10, this is going to be 100. This is going to be 10 to the power 6. This is going to be 10 to the power 8. So we're noticing that as this is going to negative infinity, this is still going to positive infinity. Then let's look at what happens to x cubed. So x cubed, this time there's going to be negative 1,000. And this is going to be negative 10 to the power 9. It's going to be negative 10 to the power 12, because whenever you cube negative numbers, the result is negative. So this is going to negative infinity. So maybe before we conclude this, let me just do a little small graphical representation of the situation. So we know that the graph of x squared is a parabola U-shaped. Now, so this is x here, this is y. This is showing us that as x go to negative positive infinity, y goes to positive infinity. So when x is here, y is here, x is there, y is now there. So as this is growing this way, y is growing that way. So as this goes to positive infinity, that is also going to positive infinity. So this is y equal to x squared. But it's the same situation as x goes to negative infinity. So as x goes to the left, as x goes this way, y is still going to positive infinity. However, the graph of x cubed, so the graph of x cubed is going to look something like that. Okay, so what you notice with this graph is that as x goes to positive infinity, y is still going to positive infinity. But this time, as x goes to negative infinity, y is now going to negative infinity as well. X goes this way, y goes this way to negative infinity. It's going to be the same situation for x to the power 5, x to the power 7, etc. So let's conclude. So the conclusion is that the limit of x to the power n as x goes to infinity is infinity as well. However, the limit of x to the power n as x goes to negative infinity depends on whether n is even or odd. If n is even, the limit is positive infinity. If n is odd, the limit is negative infinity. So that is the conclusion from this first investigation. Then next we're going to do the same investigation. So next we investigate the behavior of reciprocal powers of x this time. So we investigate the behavior of 1 over x to the power n. N is still positive. Again, we're going to look at the two cases. As x goes to infinity and also as x goes to minus infinity. So let's start with the infinity case. So again, we're going to have these values of x. So if we start with x equals to 10, then go to x equal to 100, and x equals to 1,000, this is going to be good enough this time. First, let's look at 1 over x. So when x is 10, 1 over x is 0.1, and x is 100, this is 0.01, and this is 0.001. So, well, let's just do a quick number line here to see what is the progression here. So if you imagine that we have got a number line here, and imagine that this is 0.1. Okay, so that means if you divide this into 10, 1, 2, 3, 4, 5, 6, 7, 9, 10, then this is 0.01 there. So when x is 10, so our y is here. Then when x is 100, our y jumps to there. When x is 1,000, then our y jumps to there. When x is 10,000, it's going to be even closer there. So basically you can see that as this is going to infinity, this is going to 0. For 1 over x squared, the rate at which it's going to go to 0 is going to be even quicker, because when x is 10, this is already going to be 0.01. When x is 100, there's going to be 3 zeros here, so this one is going to go to 0 even quicker. Right, now well, how about as x goes to negative infinity? Okay, so let's bring back same table here, 10, 100, 1,000. Perhaps we're just going to do the one for 1 over x, negative this time. Okay, so when x is negative 10, this is going to be negative 0.1, negative 0.01, negative 0.001. So if we come back to this number line, so this time these numbers here are coming from the left. So when x is 10, our y is here. When x, that's negative 10. When x is negative 100, then it jumps to here. When x is negative 1,000, then it jumps to there. So again, this is going to 0. It's just that it's going to 0 from the left. It's going to be the same thing for 1 over x squared. So we can conclude, okay, we can conclude that the reciprocal powers of x, whether x is going to plus infinity or minus infinity, these will always go to 0. Because if you like, what's happening with these is that you have got a fraction and the denominator keeps becoming bigger and bigger and bigger. And whenever you've got a fraction whose denominator is becoming bigger and bigger, then the value of a fraction is going to 0. Right. Before we continue, let's just make a note with limits of the exponential functions and the logarithmic function. So just going to sketch the exponential function here. So going to remember that y equal e to the x looks like that. That is 0, 1. And then this one is y equal to e to the minus x. So let's take y equal e to the x first. So you're going to notice that as x become bigger and bigger, y is becoming bigger and bigger as well. So as x goes to infinity, y go to infinity. So limit of e to the x as x goes to infinity, it's going to be infinity. And then as x goes to negative infinity, this time y is going to 0. So limit of e to the x as x goes to negative infinity is 0. And then this one, the behavior is the exact opposite. So this time, as x goes to infinity, so here, if x is going to infinity, y is going to 0. And then as x goes to negative infinity, so as x is going this way, y is going that way. So e to the minus x as x goes to infinity, that one is 0. There's negative infinity here, so that's infinity there. And then for the log, you're going to recall that the graph of the log is going to be it's going to look something like that. This is 1, 0. So this is y equal to ln x. So again, you can see that as x goes to infinity, x is going this way to infinity, y is going that way to infinity. So the limit of ln x as x goes to infinity is also going to infinity. And then as x goes to 0, as x goes to 0, as x goes to 0 like this, from the right, of course, y is going down to negative infinity. So limit of ln x as x goes to 0 is negative infinity. All right. Before we do some examples, just two things to talk about. We are going to be interested in limits of rational expressions, okay, as x goes to plus or minus infinity. So to evaluate limits of the form x goes to plus or minus infinity of f of x over g of x, where both f and g are polynomials. Both f and g of x are polynomials. There are two ways we're going to do this. The one way is that we are going to divide all terms by the highest power. Highest power of x in the denominator. Okay, so since we're doing this limit as x goes to infinity, then definitely x is not equal to 0, so we can divide by x. So we just look for the highest power of x in the denominator, then we divide everything by that power. Then after we've done that, we simply perform direct substitution. Okay, so that's going to be the one method. The other method involves a dominant balance analysis, which we will show as we go through the examples. Okay, then before we go through some examples, let's look at some arithmetic results involving infinity. So the way we do arithmetic with infinity is a bit let's say interesting. Okay, so we are going to, let's imagine that alpha is a non-zero positive number. So let alpha be a non-zero positive number. So what we're saying is that alpha is bigger than 0, but it is less than infinity. Then the following results will apply. So alpha plus infinity, alpha plus infinity is going to give us infinity. So in this way you can see that infinity is dominating the situation there. Also alpha minus infinity is just going to be negative infinity. So in these two results, alpha is behaving a bit like 0 because it's being dominated by infinity. You know that 0 plus any number is just going to be that number. Then if we multiply alpha by infinity again, we're going to just get infinity. Remember we said alpha is positive. And then also if we say infinity divided by alpha, we're still going to remain with infinity. Then infinity is going to obey the laws of directed numbers. So negative alpha times negative infinity is going to be positive infinity. Negative infinity times negative infinity is going to be positive infinity, which implies that negative infinity times negative infinity. All right, so this is going to be negative infinity. Then infinity plus infinity is infinity as well. However, infinity minus infinity is not necessarily equal to 0. So this one is what we call the indeterminate form. Remember we've already met indeterminate as in 0 over 0, and we said indeterminate means it's something that needs further analysis. So here infinity minus infinity could be 0, but it's not necessarily 0. Similarly, infinity over infinity is a bit like 0 over 0. Is not necessarily equal to 1, So this is another indeterminate form that requires further scrutiny, further analysis. We will see some of these, especially, well, definitely this one. We will see how to handle those. Sometimes we use the binomial theorem and stuff like that. Okay, so I think we're going to end this video here, and then in the next one we are going to look at some examples. Thanks for watching. Yeah, so